What did we see on the homework that was confusing? Or what do you got, Bub?
I'm going to do number
4. So that's on the back side, yes?
Yeah.
Okay. So everyone should have a packet out. If you don't have your packet, you left it at home, let me know. I got extras. I printed too many.
I mean, it's not even just the
Number 4, huh? Okay. So it says to get to work, a commuter must cross train tracks. Okay, does that mathematically have anything to do with the problem? Probably not. It says the time the train arrives varies slightly day to day. But the commuter estimates he will get stopped on 15%. He'll get stopped on 15% of his work days during a certain 5-day work week. What is the probability that he? Okay. So he's talking just about some sort of train tracks. So on problem number 4, this person, they're driving their car. This is their fancy car. Okay, going this way. Commuter's going to have to cross railroad tracks. And he says about 15% of the time, he'll have to wait at the train crossing when he goes to work. That's all it says. Okay. He doesn't know, it doesn't have any days that, in particular, that he has to wait by the light. So they want to know what is the probability that on Monday and on Tuesday he gets delayed. Okay, so think back to yesterday. When we used and, did we multiply or did we add?
No, I'm just kidding.
Multiply, right? Okay, so if we have and, this means we need to multiply. So I'm going to take 15%. 15% is 0.15. Agree? And I'm going to multiply that times 0.15. If I multiply those together, well, 15 times 15 is 225. Right? But I have to move my decimal this way. So 0.0225, which comes out to, he has a 2.25% chance of having 2 days in a row that he will have missed or have to wait for the train to cross. So it's more likely, if he had to wait for the train on Monday, the probability that he has 2 days during the week is dropped significantly.
Well, wouldn't you estimate that answer?
I don't have to estimate when I have an exact value.
Wait, but I thought.
Right? Keep asking. You have a question. Why would I estimate? Because I'm just curious. Why would you estimate?
I thought you were putting 2% as days. Like you're saying.
So he has a 15% chance, no matter what day he goes, that he'll have to wait for a train.
Okay.
So what's the chance that he has a Monday and a Tuesday? So he has a 0.15 chance on a Monday, a 0.15 chance on a Tuesday, or 15% chance on each day.
I thought you were saying like 2 of 100 days.
Yes, ma'am?
I just don't. So like, I just like don't get how you got to 2.25%.
So 15% is 0.15 as a decimal. Do you agree with that?
Yeah.
So all I'm doing, because it's and, they said Monday and Tuesday. So I'm going to multiply 0.15 times 0.15. Well, 15 times 15 is 225. And then 0.1515. I have to move the decimal back 4 spots. So I have to put a 0 as a decimal.
Okay, so just whatever the percent is, you just multiply that together.
And when it says and, yeah. Okay, so that's the first problem. That's A. Okay. And then it says get stopped for the first time on Thursday. So let's think about this for a second.
Is this a new problem?
Well, this is just B to number 4. So what's the probability? So Monday, Tuesday, Wednesday, Thursday, Friday, right? They want to know that this is when he had to stop. So he's able to make it Monday, no problem. Was able to make it Tuesday, no problem. Was able to make it Wednesday, no problem. Dang it, the train stopped me. Okay? Are we worried about Friday right now in this whole problem? No. So Friday we're not worried about. So we're going to kind of eliminate that. So how many days am I really talking about right now? 4. We good? All right. So I have an 85% chance that I didn't have to stop for the train on Monday. Okay? Does the train know it stopped you on Monday? No. The train's just going through and you have to be just sitting there, right? It's not like the guy driving the train going, oh, that's that red car again. No. The train goes by. So there's an 85% chance there. This is also an 85% chance. And this is also an 85% chance. Agree? So what I'm going to do here is I got stopped here, but what's the probability that I made it through? Here. I'm ignoring all of these. What's the probability that I don't get stopped here? Because again, the train doesn't remember if it stopped you or not.
85%.
Still have an 85%, right? That's still 85%. Okay, now, I gotta grab a calculator because I can't do this kind of math in my head that quickly. I'm sorry, I know some of you think I'm unbelievable with math. I gotta understand that I can't even count to 3 most days. Okay. So let's first off, let's figure out the probability that, because we're worried about Thursday being the first day we had to get stopped by the train, right? Does it make sense? So what I'm going to do is I'm going to multiply 0.85 times 0.85 times 0.85 times 0.85. So that's Monday, Tuesday, Wednesday, Thursday that I didn't get stopped by the train. And then what I'll do, whatever that answer is, I'm going to go 1
Thursday you did get stopped.
I understand. You're totally right. So what I'm going to do is I'm going to figure out the probability that I didn't get stopped on 4 days. Okay? And then I'm going to go 1, subtract whatever that probability is. That'll give me the probability that Thursday I got stopped. Okay? It actually gives you the probability you got stopped on 1 of the 4 days. Okay? And that's different. So I want you to think about that. So the thought on the probability, and this is really hard to fathom. And let me take a step back before I continue the rest of this problem. Okay? Would you feel that you, at some point in your life, might play the lottery, the lotto, the Powerball? You know, it was just like, it was almost $1 billion a couple weeks ago, right before Christmas. You remember that? Yeah, it's like a ridiculous amount of money, right? So everyone agrees that the Powerball is, one, if you were to win it and be the individual winner, that's life-changing, financially. Agreed? Is it easy to win the Powerball? No.
Yeah.
If the answer is yeah, it wouldn't be it wouldn't be a moneymaker. It wouldn't be a cash cow for the state. Basically, all the Powerball or any of the state lotteries, do you want to know what they really are?
Scams. Just to get your money.
It's to get your money. So what's a way that the government tries to get our money? What's that called?
Taxes.
It's called taxes. The lottery is a voluntary tax system. Okay? So like if we go over to the store and we buy something, we have to pay a tax on it, right? It's not necessarily voluntary. You know, you can't say, hey, I don't want to pay taxes on it. Like the store is going to incorporate whatever the tax is on the stuff you buy. The lottery is a way to improve the amount of money that the state is bringing in by giving you a game of chance to play, which is basically a tax. Okay? It's kind of weird to think of it that way. So here's the scary thing. I think the Powerball takes, you have to match 6 numbers or 5 numbers, and then there's a whole nother bin of the Powerball, and then you have to match that. And I don't remember what all the numbers are, but let's say there's a total of 80 balls that are in this thing, in which their little contraption is going to shoot out 5 balls that have different numbers on each one. And then there's another bin of 80 red ones, and the machine's going to spit out, and these all have numbers on it. Okay? Here is the most gooped up, scary thing in the world. So everyone says, hey, I have a system of how I'm going to win this. Okay? I'm going to pick my birth date, when I first met my girlfriend, how many kids I have. You know, they're going to figure out some sort of way that that's the way they're picking numbers. That's great. Or you can go in and say, hey, just have the computer pick the numbers for me. Or you could just go in and arbitrarily say, I'm going to figure out 5 numbers to pick and which Powerball to pick. Okay? The chances that 1, 2, 3, 4, 5, and then the number 6 come out of the Powerball is the exact same probability of any other combination of balls coming out. The amount of combinations that work that way, if you have 80 balls and you're choosing 5 of them at random, and then I'm going to multiply that times 80 balls where I choose 1, it's close to the trillions. And you're saying, I'm going to pick 1 out of a trillion.
Combinations.
Yeah. But one of those combinations is going to work. But when you talk trillions, like, it's so hard to fathom a trillion.
So it would take like NASA like 20 years to develop the answer of the combination for the lottery.
So it's just a matter of chance of which ball is coming out. So this is the goofy thing about how the lottery works is I'm giving money. Your chance of winning money when you play the Powerball or the big jackpot things is so very low. Do people win? Yeah. Do they have a system to how they win? No. There's not a system to make you win. But you have like 1 out of a trillion chance of getting the sequence of numbers that you need. I mean, your probability of getting hit by lightning, you have probably a chance. You have a chance of getting hit by lightning 5 times in your lifetime. So you're more likely to get hit by lightning 5 times in your lifetime than you are matching up the Powerball. That's crazy. I mean, just think about it. It's goofy. Now, we've all seen on the news there's some village idiot out playing golf on a lightning storm and he gets nailed by lightning. The guy's a moron. Okay, so I'm going to swing a piece of iron like this during an electrical storm. I'm going to create a static charge on my body because I'm going to wear, a rain repellent jacket. Well, of course, lightning is looking for the fastest route to the ground, and just because you're 5 or 6 feet tall, that route to the ground is now a static charge. So lightning is going to say, I'm going through the air. Oh, I can get to the ground faster going through this moron than if I just hit the ground directly. Now we're talking about an inkling amount of time. But that's really what lightning's doing. It's finding the path of least resistance to hit the ground.
How many volts are going through your body when you get struck by lightning?
Lots. I mean, if you live by getting hit by lightning, you are really lucky. I mean, it's enough that it's basically the amount of heat. It's about in the 20,000 degree range. So figure 20,000 degrees going through your body.
Well, what if you're in like Antarctica?
20,000 degrees still is 20,000 degrees. It's gonna go.
Just ice cold water.
And I tell you, lightning when it hits a body, it's actually a really pretty pattern that your skin makes.
I've seen
Oh,
it.
yeah,
It's really
it's
cool.
It's amazing. It's like, dude, this would be like a sweet tattoo.
Yeah.
Now I do not say that you should go out saying,
Even
hey, it's
down
gonna
the
lightning.
spine.
Let's take some
Wait,
nylon and do
yeah,
this and
like
create a
this
big
so
static charge and hope I get hit. It's not a good idea.
Wait, but don't a lot of people get hit by lightning and survive?
No, like only like 2 people have gotten hit by it.
Well, first off, not that many people get hit by lightning ever. But there are certain places like Colorado that are a much drier climate, which have a larger static charge, that people are getting hit by lightning. But the probability of getting hit by lightning is still very low. I mean, there are things that you can do that can increase your chances of not getting hit by lightning. Like maybe we should get indoors with this bad storm. Maybe I shouldn't be standing on the top of my roof.
I was
Turn
once in like a
With
pool
a metal
while I
pole
was
raised
like
up to the sky.
lightning. I was scared.
We always looked at it this way, and I always looked at it when I was coaching my daughter's soccer teams. It's like, oh, there's lightning 3 miles away. Yeah, but the probability of us getting
Stop
hit,
tweaking.
the probability of us getting hit by lightning is so low.
I know. That's what I said.
But people always freak out. Oh yeah, but there was this one guy. This one time, I knew a guy who, and you're like, yeah, everyone knows a guy. But you
My
gotta
boyfriend's
overthink
cousin's
communication.
best friend's uncle's sister got hit by lightning.
What if my little Jimmy dies out there?
If it's your uncle's sister,
Go ahead.
it's just your aunt.
What happens if the card that has the winning combination isn't shown? Does the state just keep the money?
So there's a certain time.
Well, is it sold? It's like still in 7-Eleven right at that moment when it's drawn.
So the numbers that are generated aren't in the computer still. Like the computer, if you were to have the computer pick your things, and when you go to 7-Eleven saying, hey, I'll take a quick pick, there's not a spiel of numbers that are already on tickets. It uses a random number generator that's going to put in the first, second, third, fourth, fifth spot, and then the sixth Powerball spot.
So they know which one is bought.
They will know if they will know if a Powerball ticket is bought, and they will know which store sold it, because every time you buy a ticket, it'll give that sequence of numbers to the big computer company that runs
What
this
if
whole thing.
More
so
than one
a card
person?
isn't predetermined.
You divide it.
So a card isn't predetermined.
That's
The lottery, like the scratch tickets, those are.
Yeah.
But the ones that you're actually printing out on thing, it's not predetermined. It's a random number generator used, unless you are telling them, hey, I want to choose these particular numbers. Then you're being the random number generator, which, but it doesn't matter if you randomly choose numbers or if you have a sequence of numbers that you always pick. Your chances of winning are always going to be the exact same, because the balls don't remember, oh, I was drawn last week, therefore this week I'm not going to be drawn. It's always going to be the same. Yeah.
I mean, just as like a default, like when you said there's like a trillion ways, like 1 in a trillion chance. How long would it take everyone in the world to play the lottery for it to get like $1 million?
Well, I would tell you this: being that you have about 1 trillion combinations to come up,
You have the whole world play.
you don't have enough machines throughout all the states to do the Powerball to print up all the combinations. It's something like 14.5 years it would take all the machines to print up all the combinations that could come out to guarantee a winner.
It can only be double-digit numbers at most, right?
Well, how a number generator does it, it could be single digit. So it's going to
I know it could be single-digit and double-digit, but can it be like? It can't be like a triple-digit number.
No. So it'll say that 1 is actually 01, and 2 is 02, and 3 is 03.
Oh,
So that's how we do it. So it's kind of goofy. So let's get back to this guy crossing the train tracks with his car.
Oh yeah.
Okay? So let's find the chance that he makes it Monday, Tuesday, Wednesday, Thursday through without the train interfering with him. So I'm going to take 0.85 and I'm going to multiply it times itself 4 times, okay? You following the math I'm doing? So I'm just going 0.85 times 0.85 times 0.85. Some of you might realize that is 0.85 raised to the 4th power. But if I were to multiply these all out, I get 0.5220. So that's 52.2%. So the probability that this particular person was taking only 4 days, and on one of those days, which they're saying, hey, it has to be Thursday. Doesn't matter if it's Thursday or Monday. The probability that this person goes 4 days in a row without the train interrupting their work, they have a 52.2% chance. Okay? So now I'm going to go 100, because we're in percents, minus 52.2. And again, these are both in percents. I can put the percents in there. So that's going to give me 47.8% chance. So our person has a 47.8% chance of having to be stopped by the train 1 out of 4 days. They're happen to say, hey, it has to be Thursday. But again, you have to realize the train doesn't remember if you got stopped yesterday. Okay? Kind of goofy. It's weird to think about. It's a much different thought process. And don't worry, second semester of this is not just all this. We just have basically Tuesday, Wednesday, Thursday this week, and Friday this week, and Monday. And then on Tuesday, we have a quiz. And don't worry, the quiz will not go real deep on this stuff. Yeah?
Are you going to mark them?
Do you got a mark on yours yet?
No.
I'll mark it.
I don't either.
I'll mark it eventually. All right, so now, number 4C says, hey, this guy got stopped every day. He got stopped every day. So we have a 15% chance that he gets stopped on any given day, right? And there's 5 days that this guy's going to work. I know there's 7 days in the week, but we're assuming he works in a 5-day week. So that's 0.15 times itself 5 times, right? Do you agree? So is there a chance he could get stopped by this train every day? Yeah. Again, does the train remember if it stopped you yesterday or the day before? No. Okay, so that's the decimal. If I wanted to make it a percent, I'm going to multiply this by 100, which moves the decimal twice. So he has a 0.00759% chance of getting stopped by the train every day. Pretty low, isn't it? Like if this guy went to Thursday getting stopped by the train every day, he's got a pretty darn good shot at not getting stopped on Friday. Unless maybe he's that guy who loves trains. And I can't wait to watch the train. Okay? And then letter D says he gets stopped at least once during the week. So he gets stopped at least once during the week. Okay. So let's do it this way. So we have our 85% Monday, Tuesday, Wednesday, Thursday, and Friday. Agree? That's the probability he doesn't get stopped. Okay, so I'm going to go 0.85 times itself. And so the chance that he does not get stopped comes out to 0.4437. So that is 44.34% chance. That's the chance he doesn't get stopped. Okay? So then I'm going to take 100% and subtract that from 44.3%. Minus 44.34. So that means he has a 55.66% chance of having to stop for the train at least one day. Okay? Huh. This is weird stuff. It makes you think in a little different way. How'd you do with this? Is there any other questions you might have come across on this? We good? You feel all right? Put a top mark on it. If you're here, I'm giving you the points for it right now, in a few minutes. Got it?
Wait, what about the homework?
They said put a top mark on it. I'm going to put the points in for you.
Oh, that was.
Cool? All right, so, oops, wrong page. Where's this? So we got pretty short notes today. We should be able to get done. It's 4 total slides, so only a front and back. And the thing is, probability, it's a real goofy thing. I actually find it as a very fascinating math that is out there because not a lot of people understand it, and I kind of like being the prima donna that gets it. Not because I think I'm better than you guys. I've come across so many people out there that are my age that have no clue to what statistics really is all about. Okay, so let's talk about a couple things on here. First thing I want to talk about. So let's say I have a quarter, and I'm going to take my quarter and I'm going to flip it 10 times. You still with me in this story? Would you think that there's anything wrong with my quarter if I tossed a coin, I just flipped the coin and let it flip and hit the ground, picked it, recorded it, picked it up, flipped it, hit the ground. Would you think there's anything wrong with my quarter if 8 out of the 10 times heads came up? You think something wrong with it? No.
That's actually true though.
No.
Look it up.
Has nothing to do with it. It won't make it happen. Trust me, I have a degree in math.
Damn, Oliver, he's really doing this to you.
So, or what about if I were to take a pair of dice? If I take a pair of dice, we add up whatever on top, right? We've all played some sort of board game that has a pair of dice.
Yeah.
So if I take a pair of dice, I can roll a 2, a 3, a 4, a 5, a 6, a 7, 8, 9, 10, 11, or 12 because I'm summing up the 2 die. In order to roll a 1 or a 2, I have to have a 1 and a 1. In order to roll a 12, I have to get a 6 and a 6. Make sense?
Or you could get.
Or so many other combinations, right? So let's say I have a pair of dice, and I roll the pair of dice, and I get a 7. And I pick it back up, and I record the 7. And I pick it up, and I roll it again, and I get a 7 again. I pick it up, and I roll it again, I get another 7. Do you think anything might be wrong with that pair of dice? It's your lucky day. That's what I'm looking for, Oliver. That's exactly what I'm looking for. So, unless somebody has created a way to cheat with dice, which I know that there are people in Vegas who have put weighted die on the table. Okay, it's a real thing. So it gives you a probability that a certain side is going to land flat on the ground, and then on the opposite side will show upward more often. But if you're playing with a pair of fair dice, if you were to roll 3 7s in a row, the thing is, those dice have no idea what they rolled last. They don't know what they added up to last. It's an inanimate object. The only person who knows that it happened is people standing around watching going, hey, look, a 7 came up. Hey, wow, he rolled another 7. Dude, another 7 showed up. Okay? Go to jail.
Wait, how do you know someone's using a weighted dice, though?
So, the weighted dice, you would stay away from 7 showing up.
Yeah, because it's on the bottom side.
So what they actually do in Vegas, there's a machine they take and they go point to point, put it like on an angle, and they'll spin it, and the little machine that's holding it can tell if it's weighted, it's gonna wobble in the thing, and that's you have loaded dice. That's how it does
Get
it.
out of here.
But actually, in order to show that if you were to roll a 7 and a 7 and a 7, it's a 1 out of a 216 chance. That's not that hard. I mean, I just talked about 1 out of a trillion winning the lottery. So 1 out of 216 seems like, dude, we could do that all day long, right? So just a few things to think about. So on this first one, let's see. I don't know what's wrong with my thing. I can't get my data to show up. Where is it? I know I can see it, but oh, there it is. There we go. All right, so categorical data is information that is in a category or descriptive, not measured. Okay, so categorical data would be, yay, buddy. Categorical data would be like this. Whoever has white tennis shoes on. Okay, so we just go and say count. Whoever has white tennis shoes on. Whoever has blue eyes. Whoever has brown eyes. Whoever has brown hair. Red hair. Less hair than everybody. Me. Okay. Whoever's wearing a blue shirt. Who's ever wearing black pants. That's categorical data. Okay? That's just like you're observing going, oh, look at that. There's all of this that I'm counting. Bivariate data is data from 2 variables per subject used to analyze relationships. I noticed that people that are all 5'9" tall weigh 180 pounds. So I'm taking the height and a weight. I notice people who drive 4-door cars with 4 passenger doors on it, average more kids, or have 2.5 kids per family. I'm just,
How do you have 2.5?
Yeah, I was like, you have half a kid.
we sever a kid in half. We got a kid who's missing an arm, a leg, and a tooth. I'm just kidding. It's based on an average. It doesn't really exist. I told the class last year, a person who's missing a limb is a less person than, like, really? It's like, yeah, their vote doesn't count as much. Like, are you serious?
My brother's paralyzed, half of his body's.
Yeah, my kid's in a wheelchair. Like 5 arms, man.
All right. A contingency table. Contingency table is tables that displays the frequency of 2 categorical variables. Okay? And then a conditional probability is the probability of event A given that another event has already occurred. Okay, so that's just kind of the definitions. It's not something that we're going to stick by and hold by and say, dude, what is this? But it's going to start applying to this next problem. Okay? So this is a contingency table. So this is talking about people who are right-handed and left-handed, and we have males and females. Okay? And it's summarizing the results from a survey of a class to break down students by gender and which hand is their dominant hand. Do you understand what we're looking at now? Okay? So we want to start answering the questions that are based on this. So how many people were in this survey altogether? 100 people. Everyone feel comfortable with that? And of those 100 people, we had 43 males that were right-handed. We had 9 males that were left-handed. We had 44 females that were right-handed and 4 females that were left-handed. We had 87 people in total that were right-handed. We had 13 people in total that were left-handed. That includes boys and girls. We had 52 males in total, and some males were right-handed, some were left-handed. And of the females, how many females did we have in this survey? 48. So do you understand how that table works so far? Okay, so we want to answer these questions. So it says, what is the probability that I randomly select a student that is a male? Okay, so this is how we're going to look at this question. I have this whole network of people standing there, 100 people. It accounts for guys and girls. Of those guys and girls, some are right-handed, some are left-handed. Still with me in this problem?
Yes, sir.
Okay, so what is the probability that I were somehow to randomly select of those 100 people that would be a guy? How many guys in total are in this survey? 52, right? So I have a 52. Oops. I have a 52. How many people total are there in our survey? 100. Now, I could reduce that, or I could realize that it's a 52% chance, because it's easy when you have something over 100, right, to make it a percent. We good so far? Okay, now the next one is, what is the probability that I randomly select a student that is right-handed? So how many people were right-handed in our survey? 87. Out of how many people? 100. So what's the probability that I pick a right-handed person? I have an 87% chance. Okay.
Wouldn't you know someone's male or female?
Huh?
Actually, never mind. I can't say that.
Okay.
It's 2019.
Yeah, I can't say that. I'll get myself in trouble.
Letter C. What is the probability that a randomly selected student is left-handed? Left-handed is a left-handed female. How many left-handed females? 4. Right? How many people are we still talking about in the survey? 100. So what percent chance? 4%. You guys are nailing it. Does that make sense? Feel good about that so far? Okay. So this question gives you a little extra information. It's still related to our top chart. What is the probability that a randomly female, what is the probability that a randomly female is right-handed? Okay, so we're talking about females. How many females are in our study? 48. How many of them are right-handed?
44.
So we know, so it's basically this. All right, all females, get over there. Okay, all males, stay over there. Okay, you go to the females. You pick somebody at random, and you're like, are you right or left-handed? I'm right-handed. Okay. You understand the scenario? So there's 48 total. So we have 48 total. And how many was it that were right-handed? 44? Hey, how do I find that as a percent? Yeah, just divide it, right? I don't have to reduce the fraction. So I'm going to go 44 divided by 48. So that gives me 0.917. So this is actually a 91.7% chance that if I were to separate the males and females, go over to the females and say, pick somebody and say, are you right-handed? I have a 91.7% chance of that happening. Okay. What is the probability that a randomly selected male is right-handed? So how many males were we talking about?
It's 52.
I had 52 males. How many of them from your chart are right-handed? There's 42? 43 right-handed males? Okay, so now I'm going to go 43 divided by 52, and that gives me 82.7%. So if I have the males, the females separated. I go over to the male group and say, all right, pick somebody at random. Are you right-handed? I have an 82.7% chance of that happening. What is the probability a randomly selected right-handed student was a male? Ooh. All right, so we go back to our chart. How many students in total are right-handed? 87. How many males are we talking about? So I have 43 out of 87. And if I go 43 divided by 87, I'm going to get 0.49. So it's 49.4%. So this then changes it saying, okay, if you're right-handed, everyone get on this side of the room. If you're left-handed, get on this side. So you have boys and girls, male and female, male and female. I walk up to the right-handed group and say, pick somebody, because you know they're all right-handed. Oh, it's a guy. Now it's like, well, of course, you can tell guys versus girls. Well, let's just pretend everyone has a number on them, and we're going to select a number at random. Okay? Huh. That's not too bad. Can I move on? Again, this stuff should kind of make you think a little bit, but a lot of this stuff is how a lot of decisions are made, and unfortunately, a lot of decisions are made based on data, and they're not based on real statistics, and that's bad. Okay, this is a contingency table of blood types. Okay, we have males and females, and we have type A, type B, type O, and type AB. There looks like there are 40 people that are males in this group, and there are 60 people that are females. And I can figure out the rest of this table. I could say, well, that means there are 37 people, if I add those together, that are type A, and there are 13 type B. And type O looks like a lot higher percent, so that's 45 of them. And then I have 5 people that are AB. Okay, and so if I add these red numbers up, coming down this column, saying, hey, what types of blood, that would also add up to 100. So what is the probability we select a person that is male? Well, there's 40 males out of 100 people. Well, that's 40%. Okay, you have all your 100 people out there, and you're like, pick a name on the list and say, so-and-so, come on forward. Oh, they're a guy. 40%. What is the probability that you select a person who has type B blood? Well, how many people did I say have type B? 13 out of the 100 people. So of our people, we have a 13% probability of going to my entire group of 100 people, picking a person at random, and they happen to have type B blood. Okay? What is the probability a randomly selected person has type A or type O blood? Type A and type O. Type A looks like 37 people. Type O is 45 people. So 37 added to 45. Did I do that math right? So it's 82 people out of 100. So I have an 82% chance. So you're just talking about a larger combination of people. And what is the probability that a randomly selected person is male or has type O blood? Ooh, okay. Okay, so how many males were we talking about? So eyes up here, watch this real quick. Oops, shoot, didn't mean to do that. Sorry about that. So this is my males. Agreed? Agreed? But this is the number of people with type O blood. That's 45. Are some of those males already in here? Yeah, we have 18 of them. So you don't want to count twice. So I have 27 and 40 that I'm going to count. I'm going to count 40 because that's all the males. And then I'm going to count 27 because that's the females with type O blood. I don't want to count the group of people twice. So that's going to give me a 67. So I have a 67% chance, 67 out of 100, 67% chance of picking somebody that is a male or has type O blood. All right, so pay attention to the denominators. What is the probability that the randomly selected person was male? So all the guys get over here. Given, oh no, I take that back. Everyone with type O blood, get over here. Oh, okay. So all the type O blood people walk over there. There happens to be 45 of them. And then probability they're male is 18 out of 45. Okay, almost done. Give me time. And then this one. What is the probability a randomly selected person has type B blood? All right, people. Anyone type B blood, go over here. Okay, so they're now all over here. You walk up and say, are you a female? So type what blood? Type B. Type B blood. So there's 13 people. And that are female. 6 out of 13. So, y'all know what homework would probably be tonight? Yeah, so pages 2 and 3 for tonight. Oh, wait, pages 3 and 4. Thank you. So it's the front and the back. And again, I don't know if the bookstore has in your workbooks yet, but be sure to head over there and see if you can't pick that up between now and Tuesday next week. Get out of here, guys, girls. Take care of one another. Someone flip the lights on for us, please.